You'll notice it's not daylight. In fact, it's after 8 p.m. I was rather late going to bed last night, hence I woke up late, and then I just ran out of daylight. It was about 5 by the time I finished the board. Writing up the board takes hours, and as it gets a bit harder, I need to think a bit more, because it's, if there's stuff to learn, if I'm not totally familiar with it already, then that learning tends mostly to occur during the writing up the board stage. And it was my wife's birthday yesterday, so this evening we went out to celebrate. Went to a Western style steak house. So we're only now getting back, and we'll do the filming part. Now, interestingly, yesterday, for the last few days, I've been experimenting with YouTube, because I noticed one time, almost by accident, I had 2 YouTube windows open in parallel, and I sent one upload queue, like several, using one window, and a separate window in parallel, with a separate queue of video clips to be uploaded to YouTube. And I noticed that they seem to upload at the same rate, and it didn't slow down, as if I only had one queue. And that prompted me to think, well, what if I had multiple queues and had less video clips in each queue? So the logical extreme of that would be, well, for example, yesterday I had 9 video clips to upload to YouTube. That's a typical number. If I do one board per day, so it's 4 sessions, and I seem to be doing roughly 1 clip per square. That's what it works out at. So about 8, 9, 10, that sort of thing. So yesterday was 9. So as an experiment, I just I opened 9 windows to YouTube. So I just clicked on the icon that opens the upload window to YouTube, and I put 1 video clip in each window. So I just had 9 uploads going on at the same time in parallel to YouTube, and I finished the whole batch, all 9 of them, in 2 to 3 hours. So now it's still the time necessary to upload 1 clip, 10, 12, 13 minutes, that kind of thing, still takes a long time, 2.5 hours typically. But with this new trick of having multiple streams, if you like, having a whole bunch of them in parallel, the total upload time for a day's filming is just a couple of hours. So that means in practice that what was the upload slowness to YouTube, that issue is no longer an issue. Right? It's not a problem anymore. So great. So I was very happy about that. Like, you can imagine if put yourself in my shoes and simplified my life to such an extent that a discovery like that is sort of like a big event, because it has implications. Like if I can, I now have the option. If I can accelerate the processing of the movie, like so the YouTube upload time is no longer a problem. What's now a bottleneck is how much time is needed to process the movie with Microsoft's Movie Maker. Like I have to go through this process twice. Seems a bit redundant. Why can't I have software that just does it all once and in half the time? So I'm asking help from friends. How can I process the raw film that's coming from the camcorder much more efficiently before I upload it to YouTube? Can I do it in a better way, faster way? Because the Microsoft method I find slow. There must be a better way. I mean, why should you have to go through a process two processes to get it in a form fit to be uploaded. Surely there's, it ought to be done in one way, and presumably there are softwares that allow you to do it more efficiently and perhaps more effectively than others. All right. So if that problem can be solved, the processing time, if I can make that more efficient, then the option opens. If I sort of went to bed quite early and got up very early, like at dawn, effectively, and I would then have the option perhaps of filming 2 boards a day. Now, the part I enjoy the most is actually writing stuff on the board, because that's that's when I learn. And particularly later, when I get to higher levels, the learning process will be by far the greatest enjoyment, the most interesting part. So maybe I'll have the option of doubling my output. And given there's so much material to do, when like I advertise on my deGarisMPC website, 600 plus courses, which is sort of a joke, given the rate that I'm going at. Like, I'm only into my 3rd course, and it's already been 4 months. Okay, so at that rate, even after a decade, it'll still just be maybe 100 or so courses. But if I can double the rate, if it's a big if. With the YouTube upload time no longer a problem, and if I can also solve the processing time problem as well, then doubling the rate becomes an option. Now the other thing is, I get quite a few interviews, and someone paid me $1,000 recently for an interview. Now I'll use a little bit of that money to solve the lighting problem. I'll get a proper solution. I have soft, diffuse lighting, and brighter than this board. I looked at what YouTube is doing when it asks me, we detected a light problem, would you like us to fix it? And I say yes. But even so, I thought the solution, the result, is still a bit fuzzier. It's less clear than filming during the day. So I will now make more effort to go to bed earlier, and hence wake up earlier, and hence have more daylight time to not only write up the board, but to film it all during daylight, because the quality, the readability is superior. Other than that, can I think of anything else? Right, well, that's sort of preliminary stuff. Okay, so to the nitty-gritty. We were in the middle of going through the proof idea of the pumping. We haven't actually got to the detailed proof yet of the so-called Pumpinglemma. Pump. And in this context, pumping means effectively just to take a string and make it longer by, well, I'll get onto that. So as a bit of revision, try to see the bigger picture. So what is the point of this Pumpinglemma? Well, it's a means that allows you to distinguish between a language that is regular from non-regular. In fact, using, and it'll become clear on this board, and we'll do it several times, once I've actually finished the detailed proof, not just the proof idea, but the detailed proof, which we'll do on this board, in these 4 sessions. So once we've finished the detailed proof, then the textbook Sipser gives 5 examples of using the Pumpinglemma to show that a particular language is in fact not regular. Okay, so effectively you're using the Pumpinglemma using proof by contradiction. Okay, so you assume, when you're familiar now with proof by contradiction. So you you have a mathematical, just quickly, a mathematical statement. If P then Q, P and Q are mathematical statements. But you also know not Q, okay? And therefore you deduce using modus tollens that you're given not Q, therefore not P, right? And if you're trying to prove P, sorry, where do I start? You're trying to prove P, and if you're using a proof by contradiction, assume the opposite. Assume the opposite of P is true. In other words, you assume not P, okay? And then from that, you deduce Q. So not P, arrow Q. But you also know, for independent reasons, that not Q is true. And then using modus tollens, this rule of inference, so you deduce Q, but you know that not Q is true. So therefore, the not P that you use to deduce Q, that itself must be false. So in other words, not P is true. So if not P is false, not P is true. But not P is the same as P, and hence you've proved P. That's the typical proof by contradiction. Now you use the Pumpinglemma typically within the context of a proof by contradiction. Okay, so effectively what you're trying to prove is that a particular language is not regular. In other words, there's no DFA that can recognize it. Right? That's the definition of if a language is regular, it means that there is a DFA that can recognize it. Okay, so if you're using the Pumpinglemma to show that there is no DFA that can recognize it, and by using the proof by contradiction, what are you trying to prove? You're trying to show that the language you're talking about, call it A, is non-regular. Okay, that's what you're trying to prove. Now, by using proof of contradiction, you'll then start with the opposite of that. Right? So if it's not non-regular,
a vast virus database has been updated.
Then it is regular. Okay, so you start with that it's regular. Now, if it is regular, then you can use the Pumpinglemma, right? Because the Pumpinglemma, that's what you're able to use it if your language is regular. And then using the various conditions of the Pumpinglemma, you get some result which is actually a contradiction. It's false given other knowledge. You derive a contradiction, and therefore your original assumption is false using the